Matcom tutorials, an investment in knowledge pays the best interest.
Hi guys, you're welcome again to Matcom Tutorials, my YouTube channel. I believe you've been enjoying all the tutorial videos I've been posting, especially the solutions to past IGCSE questions. Today we are going to solve paper 2, that's multiple choice extended IGCSE question for physics 0625/21 May June 2019. Now let's go to the questions. Question 1. Which quantity can be measured directly using a micrometer screw gauge? Let's look at the quantities we have here. Micrometer screw gauge is a measuring instrument that is used to measure small length. I think, let me show you. Okay, this is a micrometer screw gauge. Now let's look at what we have here. The area of a sheet of paper. This one is out. We cannot use it to measure area. This is out. Let me change this to red. This is out. The mass is a distance measuring instrument. This one is out. The volume, no, this one is out. So the answer is C. A micrometer screw gauge is used for measuring the thickness of a paper. Let's look at the next one. The velocity of an object increases from 30 meters per second to 50 meters per second in 5 seconds. What is the average acceleration of the object? The formula for average acceleration is written here. Average acceleration, we can see it here. Average acceleration is what I've highlighted here. Average acceleration is the change in velocity divided by time. Sorry, it's like the color is blocking it. Change in velocity divided by time. That is the final velocity minus the initial velocity divided by time. Now, the final velocity here is 50 and the initial velocity is 30. So 50 minus 30, that is 20 divided by 5, that gives you 4. So the answer is 4 meters per second, that is C, 4 meters per second squared. Now question 3. A heavy metal ball falls vertically downwards through air past 4 equally spaced levels J, K, L, and M. The times taken to fall from one level to the next are measured. Where is the speed of the ball the greatest and which time is the shortest? The formula for speed is distance divided by time. Distance over time. Now, if we look at it, let's see it. The formula for speed is distance divided by time. Now, using this formula, you see that where the distance is greatest, then the speed will be the greatest. And where the time is shortest, the speed will be the shortest. Let's look at the distances we were given and look at our answers. J and K, that's where the speed is greatest. J and K, it can be here because the distance is short. J and K, so the two J and Ks are out. The two J and Ks are out. L and M, L and M. If we look at the distance, let's look at it from here to here. Between L and M, of course, that's where we have the greatest distance. So that is where we are going to have the greatest speed. Now let's look at when the time is shortest. J and K. J and K, the time cannot be shortest here because it is still moving until when it gets to this place. So L and M, that's the time that the time will be the shortest. In fact, where we have the greatest distance, that's where we are going to have the shortest time based on this relationship. So the answer here is D. Let's go to the next question. And that should be number 4. A body is moved from a place X to place Y where the gravitational field strength is different. what happens to its mass and to its weight due to the move? The first thing I want you to know is that mass is always constant. Mass does not change. So if mass does not change, this one is out and this one is out. So mass stays the same is correct, mass stays the same is correct. Now what happens to the weight? The formula for weight is weight equals mg, where m is the acceleration due to gravity. And it is written here that where the gravitational field strength is different, that means the weight changes. So the answer is C. Mass stays the same and the weight changes. The next question, the diagrams show four solid blocks with their dimensions and masses. Which block has the greatest density? Which block has the greatest density? We need to look at the formula for density. Formula for density, density equals mass over volume. So we're going to look at mass over volume for the whole of this. Now, the mass here is 14, and then the volume is area times this height. So that is 20. So we have 14 divided by 20. 14 divided by 20 gives me 0.7. Okay, I think I'll need to just type it. 14 divided by 20 gives me 0.7. 0.7, and that is the density here. 0.7 is the density here. Let's look at the one here. This is 40, and that is 48 over 40. 48 divided by 40 gives me 1.2. 1.2, that's the density here. And this one is 40 for the volume, and the mass is 68. So 68 divided by 40 gives 1.7 for this place. 1.7. And then finally, the volume here is 10 times 2, that's 20. 54 divided by 20. 54 divided by 20, what will that one give us? 54 divided by 20, that will give us 2.7. Sorry, 2.7. Okay, and the question is, which block has the greatest density? The density here is 0.7, density here is 1.2, density here is 1.7, and this is 2.7. So the answer is C. Remember how I got it? All you need to do is to divide the mass by the volume, that's area times height. Next question, that's number 6. A student wishes to determine the spring constant of a wire where it obeys Hooke's law. Different loads are hung from the spring and its length is measured for each different load. The table shows the results of the experiment. So let's look at it. Let's look at this one. The student wishes to determine the spring constants. Remember the formula? The formula force equals kx, where k is the spring constant and x is the extension. Now, how do we get the extension? Now, at weight 0, that means no weight has been added. The length of the spring is 12. That's the original length of the spring. Now, when a weight of 2 Newton was added, the length turns to 20. So what is the extension there? The extension is 20 minus 12, and that is 8. 20 minus 12, that is equal to 8. Okay, the student wants to determine the constant. This constant K is equal to the force divided by the extension. Now the force here is 2 newtons and the extension is 8. So force divided by extension will be 2 divided by 8. Let's look at it. If the extension here is 8, see extension here 8. What is the extension here? When a load of 4 Newton is added, the extension will be 28 minus 12, and 28 minus 12 will give us 16. So the extension here from here to here is 16. If we use the same formula, load divided by extension is going to be 4 divided by 16, which is going to be 2 divided by 8. So it is still the same thing. So 2 divided by 8, that is 1 over 4, and that is 0.25. 0.25. And that is the answer, 0.25 Newton per cm. Okay, let's go to the next question. The next question, question 7. Okay, a mass of 20 kilograms is held stationary by a rope passing over a frictionless pulley. What is the tension in the rope? Now you need to note this word, take note of this word, stationary. It's not moving, and frictionless. So when it is stationary and frictionless, it means the tension in the rope is equal to the weight. The tension in the rope is equal to the weight. And what is weight? Weight equals mg. Sorry, I need to clean this. Weight equals, should be capital. Weight equals mg. And what is our m? Our m is 20 times, what is our g? Our g is 10. So the answer is 200. 200 newtons. 200 newtons. That's our answer, 200 newtons. D. Okay, the next question. A boat starts moving across a river with a velocity v perpendicular to the river bank. Okay. The boat encounters a current along the river of velocity u as shown. Which vector diagram shows the resultant velocity r of the boat? Looking at this thing, okay, we have it this way. Is this, sorry, let's use this. We have it this way. This is the velocity. The velocity is coming this way, and then u is coming this way. You can see u here. If you understand vectors very well, you know that if we draw the velocity here, we can also put our u here. It is still the same direction. As far as you show the direction like this, this is the direction of u, and this is the direction of our v. In this case, the resultant is going to pass through here, and it's going to be something like this. This is the resultant. And then it must come towards this direction. So let's look at it whether there is a diagram like that. Okay, we have C. The answer is C. Okay, next question. A ball of mass 0.50 kg falls and hits on the floor at 10 meters per second. It rebounds at speed 8.0 meters per second as shown. Before collision, after collision. The collision between the ball and the floor lasts for 0.50 seconds. What is the average force acting on the ball during collision? What is the average force acting on the ball during collision. Now, if you look at this, okay, I think the first thing we need to do is to represent upward and downward velocity with signs. Okay, let's call the downward velocity negative. Downward velocity negative. So that means it's just for us to know the direction. You can change it either way. So the initial velocity, that's the velocity before collision, u, let's just call u. Let's say u is equal to minus 10 meter per second. U equals minus 10 meter per second. And this one, this is v, that's the final velocity. V equals plus 8 meter per second. Okay, we have done that. So what is next? The formula for this, there is a law that states that the rate of change of momentum is directly proportional to the force. Oh, that's Newton's second law. The rate of change of momentum is directly proportional to the force. And when we talk about the rate of change of momentum, momentum is the product of mass and velocity, product of mass and velocity. So the change in momentum is mass times change in velocity. And when we say rate, it is divided by time. Yes, this is it. So force is directly proportional to this. So it means F equals mv minus u over t. We are asked to calculate the force. So what is the value of our m? That's the mass. That's 0.5. Okay. 0.5 into v, 8 minus, what is the value of our u? 8 minus, our u is minus 10. Yes. 8 minus 10. Let me put a bracket here. Okay. 8 minus 10 divided by what is our t? The time, 0.5. 0.5. Without wasting our time, without wasting any time, we can see that 0.5 here can cancel 0.5. So we are left with 8 minus 10, which is equal to 8 plus 10. 8 plus 10. 8 plus 10. Sorry. Which is equal to 8 plus 10. And 8 plus 10 is what? That is 18. But we need to look at it at the direction. 8 plus 10. Is the 18 plus or minus? It is plus. It is plus 18. Plus 18. What did we use plus for? Upward direction. So the answer is C. 18 newtons in the upward direction. An object falls from the top of a building that is 25 meters high. Air resistance is negligible. What is the speed of the object when it hits the ground? We have to calculate the speed of the object when it hits the ground. You need to know that the object has a kinetic energy because it is moving. And since it is falling from a height, it also has a gravitational potential energy. Air resistance is negligible, so gravitational potential energy is equal to kinetic energy. What does this mean? It means mgh, that's the formula for gravitational potential energy is half mv squared. Okay, let me put this squared like this. Is half mv squared. Okay, so m can cancel m here. So we now have gh. What are we calculating? What is the speed? Okay, and this is 1 over 2. So we have 2gh is equal to v squared. This implies that v equals the square root of 2 times, what is g? 10 times, what is h? 25. Okay, 2 times 10 times 25. 2 times 10, that is 20. 20 times 25, that is 500. So we are looking for the square root of 500. The square root of 500. The square root of 500 is let's see. This is 2 times 10. That is 20. Sorry, I need to pause here so that I will take my calculator and then be able to solve. And I need to continue. All right. The square root of 500 is 22.4, so which is 22 meters per second. The next question is a machine is efficient. What does this mean? Let's look at it. It produces a large amount of power. Is that the meaning of a machine being efficient? No. It uses little energy. It wastes a little energy. Yes. When a machine is efficient, the friction in the machine is reduced. So it wastes a little energy. It wastes a little energy. It wastes a little energy. A crane takes 2 minutes to lift a load to the top of a building. The change in gravitational potential energy of the load is 360 kilojoules. What is the useful power output of the crane? Power is just energy expended per unit time. So that means the power is equal to the energy. What is the energy? 360 kilojoule. That is 360 kilojoule divided by 2 minutes. Let's convert this minutes to seconds. So that is 2 times 60, and that is 120. This 0 cancels this 0. 36 divided by 12 is equal to 3. But remember, it is in kilojoules. I didn't convert it to joules by multiplying it by 1000 because the answer is given in kilowatts. So the answer is 3 kilowatts. Okay, next question. Let's see what is there. The diagram shows a stone suspended on a string under the surface of a liquid. The stone experiences a pressure caused by the liquid. What would increase the pressure on the stone? What will increase the pressure on the stone? Okay, let's see. Pressure in a liquid. is calculated as, let me use this sign for density times gravitational force, then multiplied by the height. What would increase the pressure? The pressure will increase if it is in a place where the gravitational force increases. It will increase if the density increases. It will increase if the height increases. But let's look at it. Decrease in the surface area of the stone. Nothing is talking about the surface area of the stone here. Increasing the mass of the stone. Lowering the stone deeper into the liquid. Using a liquid of lower density. When the density is lowered, this one cannot be correct. The pressure reduces. Decreasing the surface area, lowering the stone deeper. If you lower the stone deeper, that means the height increases. The height increases. So this is the answer. Okay, next question. A stationary smoke particle is hit by a fast-moving nitrogen molecule. Which row describes the motion of the smoke particles and of the nitrogen molecule after the collision? What happens to the smoke particles? Now you see there is a way we can easily solve multiple choice question by elimination. Smoke particles cannot be stationary now. They cannot be stationary. The nitrogen molecule, nitrogen is a gas, the molecule cannot stop. So the answer is A. Let's go to the next question. And that is question 15. Okay. Question 15. A night storage heater contains a large block of material that is heated electrically during the night. During the day, the block cools down, releasing thermal energy into the room. Which thermal capacity and which night temperature increase will cause the most energy to be stored? We're talking about thermal capacity here, and we're talking about energy. Now, the relationship between thermal capacity, temperature, and energy is this. The quantity of heat, that is Q, equals mass times temperature change. Mass times specific heat capacity times temperature change. That is the relationship. Now the question is, which thermal capacity and which night temperature increase will cause the most energy to be stored by the block? The most energy to be stored by the block. Of course, when the thermal capacity increases, most energy will be stored. High temperature and high mass. So let's look. We're not talking about mass here. We're talking about thermal capacity and then temperature. So large thermal capacity and large night temperature. That is the answer. The next question. Okay, number 16. 100 grams of water at 25 degrees Celsius is poured into an insulating cup. 50 grams of ice at 0 degrees Celsius is added to the water. The water is stirred until the temperature of the water has fallen to 0 degrees Celsius. 18 grams of ice remains unmelted. The specific heat capacity of water is 4.2 joule per gram per degree Celsius. Which value does this experiment give for the specific latent heat of fusion of ice? Now we have 100 grams of water at 25 degrees Celsius. The final temperature, according to the question, has fallen to 0 degrees Celsius. That means the water has lost heat. For the ice, it was 50. 18 grams remains unmelted. That means 50 minus 18 grams melted. It means only 15 minus 18 grams, which is 32 grams, gained heat. Now, all things being equal, heat loss must be equal to heat gain. So heat loss by water is calculated as mass of water times multiplied by the specific heat capacity of water and then the temperature change, the formula that we have here. The mass of water is 100 grams. The specific capacity of water given is 4.2 joule per gram per degree Celsius, and the change in temperature is 25 minus 0, which is 25. And this will give us 10,500 joules. For ice, the heat gained by ice, is equal to, let me change this, mass of ice multiplied by the latent heat of fusion of ice. And the mass of ice is 50 minus 18, that is 32. 32 L. So if heat loss is equal to heat gained, that means, let me do that here. 10,500 must be equal to 32L. 32L. So if you divide both sides by 32, you find your L. So L, that's what we are asked to find, the specific latent heat of fusion. So that is 10,500 divided by 32. 10,500 divided by 32, and that will give us 328.1, and that is 330. As the answer, the next question, in which does thermal conduction not occur? In which does thermal conduction not occur? A gas, a liquid, a solid, and a vacuum. The answer without wasting time is a vacuum, because conduction requires a material medium for transfer. Next question. That's number 18. The metal surface of a kettle is hot. What happens to the cool air outside the kettle when it comes into contact with the metal surface of a kettle is hot. What happens to the cool air outside the kettle when it comes into contact with the hot kettle? The air outside the kettle. Now, when it comes in contact with the hot kettle, the temperature of the air increases. And when the temperature of air increases, the volume also increases. Remember that density is mass divided by volume. When the volume of the air increases, then it becomes less dense. Let's check whether we have our answer. The density of the air decreases. The density of the air decreases and the air falls. When the density decreases and the volume increases, when the volume of air increases, it expands. And when air expands, it does not fall, it rises. So the density decreases and the air rises. This is the answer. Some hot water is sealed inside a metal can. The can is in a vacuum in outer space. The hot water slowly cools down. How does the thermal energy escape into space? How does the thermal energy escape into space? Okay, some hot water is sealed into a metal can. Okay, let's look at the answers. The can is in a vacuum in outer space. The hot water slowly cools down. Since it is a metal, because how does thermal energy escape into space? But the water is inside. Since it is a metal, heat will be transferred by conduction in the metal. And since there is a vacuum, heat is also going to be transferred by radiation. So this is the answer. The next question, when water waves pass through a gap, they diffract. Yes. The diagrams show wavefronts approaching a narrow gap. In which diagram will the diffraction be least? Let's look at the diagrams and check which one has the least diffraction. Here, the gap here is actually smaller than the wavelength of the wave, so it curves around this place. It curves around this place, so diffraction still occurs. Here the gap is smaller than the wavelength, diffraction still occurs, but here the gap is bigger than the wavelength. So the diffraction will be least where the gap is bigger than the wavelength. The answer is C. Now the next question, which is number 21. An object is placed 30 cm in front of a plane mirror. Which statement describes the image of the object? The image of an object in front of a plane mirror, the image has the same distance from the mirror as the object from the mirror. The image is laterally inverted, the same size as the object. So let's look at the answers. The image is the same size as object and 30 cm from the object. Now, let's look at it critically. Let's look at it. Let's say we have our plane mirror here. We have our, let's call this one image. We have our image here. We have our object here. If the distance here is 30, then the distance here too will be 30. So the distance of the image from the object is going to be 30 plus 30. So the image is the same size and 60 cm from the object. This is the correct answer. Let's look at the next question. The next question. A small object O is placed near a converging lens as shown. The lens forms an image. Which statement is correct? The image I is diminished. Let's look at the image formed. The image formed is actually a virtual image because of these dotted lines. And I have a diagram here to show you the image formed by a convex lens. Let's look at the condition in which it forms a virtual image. Here the image is real and inverted. Here the image is real and inverted. Here the image is real. Here the image is real. Now here the image is inverted. In fact, wherever we have images real here, we need to cancel it because the image is actually not real from what we have there. Okay, let's continue. Now, the image is diminished. The image is inverted. And the object is here. The object O is closer to the lens than the principal focus. Let's look at the two conditions in which the images are virtual. Now this is the principal focus. The object is closer to the lens than the principal focus here. The object is closer to the lens than the principal focus here. So it is correct that the object is closer to the lens than the principal focus. Closer to the lens than the principal focus. Let me reduce this and put it here. Okay. This is the answer. The next one. An eclipse of the sun happens when the moon comes between the earth and the sun. Which statement is correct? Infrared radiation from the sun disappears when visible light and ultraviolet radiation. No. Ultraviolet radiation from the sun disappears before the visible light. No. Visible light from the sun disappears before ultraviolet radiation and infrared radiation. No. Infrared radiation, ultraviolet radiation, and visible light from the sun all disappear at the same moment. This is the correct answer. They all disappear at the same moment. Question 24. A pulse of sound is produced at the bottom of a boat. The sound travels through the water and is reflected from the shell of fish. The sound reaches the board again after 1.2 seconds. The speed of sound in water is 1,500 meters per second. How far? That is talking about the distance. How far is the boat? How far below the bottom of the boat is the shell of fish? Now, distance, we're given speed. Speed is calculated as distance divided by time. Now, when the sound comes here, before the sound reaches the board again, it will go up. It means the sound will hit this place and then go up. That means it has traveled twice the distance from the boat to the obstacle. That is 2D. So permit me now to change this formula to distance is equal to, or speed is equal to 2D divided by T. So we have to calculate how far, that's the distance. So from the formula, ST divided by 2 is equal to our distance. ST divided by 2 is equal to distance. So what is our S? That's the speed. 1,500, and what was the time? Times 1.2. 1,500 times 1.2, then divided by 2. And 1,500 times 1.2, 1,500 times 1.2, 1.2 is 1,800. When you divide 1,800 by 2, it gives you 900. So the answer is 900 meters. Next question. What is the approximate value of the speed of sound in air at normal temperature? At normal temperature, the speed of sound in air is between 320 and 340. So this is the answer. Why is soft iron used for the core of an electromagnet? Soft iron easily becomes a permanent magnet. It's a good electrical conductor. No. It's a poor thermal. We don't even need anything thermal here. Soft iron loses its magnetism when the current is switched off. Yes, that is what is actually called an electromagnet. It loses when the current is switched off. It loses its magnetism, and when the current comes up, it gains. It becomes magnetized easily. Next question. Diagram 1 shows two twin uncharged strips of plastic. Diagram 2 shows the same strip of plastic after they have been rubbed with a dry cloth. Which row describes the charge on the strips after rubbing and the force between the strips after rubbing? Now, after rubbing, they repel. there is a repulsion here. That means the charges are the same. So let's look at our answers. This one is wrong. It's not opposite charging. It's not opposite. The charge is the same and there is repulsion. So this is the answer. Let's go to the next question. A cell has an electromotive force EMF of 1.5 volt. What does this statement mean? It's like asking us to define EMF. A cell converts 1 joule of energy when driving 1.5 coulomb of charge around a circuit. No. The cell converts 1.5 joule of energy when driving 1 joule, 1 coulomb of charge around the circuit. This is the correct one because it is the energy per unit charge, So 1 coulomb of charge. Which two changes to a metal wire both increase resistance? The resistance of a wire is affected by one, temperature. When the temperature of the wire increases, resistance increases. When the length of the wire increases, resistance increases. But when the area of the wire increases, resistance decreases. Let's see whether we can have an answer here. Let's see. Decrease in length. No. It is when the length increases that the resistance increases. Increase in length, yes. Decrease in temperature, no. Decreasing the thickness. When the thickness increases, resistance reduces. So when you decrease the thickness, resistance increases, yes, and increasing the temperature. That's correct. But let's look at the last one. Increasing the thickness, no, that reduces resistance. So the next question. The diagram shows a circuit containing a DC power supply, a motor, and a variable resistor. 3 ammeters X, Y, and Z show the current in different parts of the circuit. The reading on X is 4.0 ampere. Which statement is correct? Okay, it goes this way. The whole current passes through this variable resistor, and the same current comes here. The same current goes here, and the same current comes to Z. Okay, let's see the answer. The readings on Y and Z are both less than 4. No. The readings on Y and Z are both equal to 4. Yes, the same reading. Question 31. A lamp is to be connected in a circuit so that the potential difference PD across it can be varied from 0 to 6 volts. Which circuit would be most suitable? Let's look at these circuits. There are 4 circuits here. Circuit A is not going to be suitable because the lamp is connected across a variable resistor. The function of a variable resistor is to control the current. So in this case, this is wrong. The lamp will still remain at 6 volts. The same goes for C. Option C, there is no circuit component that allows line to pass through like this, and most of this is also connected in parallel. So this is wrong. For option D too, it is wrong. It is connected in parallel. The answer is option B, because if you look at option B critically here, we have a slider that you can move to control the voltage. This is connected in parallel. You have a slider that is moved to control the voltage. So this is the correct answer. Let's go to the next question. Which logic gate symbol is represented by the symbol shown? This is an AND gate. And the next question, the diagram shows a combination of logic gates. Which single gate is equivalent to this combination? This one is an OR gate, or OR gate. and this is a NOT gate. The combination of OR and NOT will give you NOR. So it is a NOR gate. Let's go to the next question. That's question 34. Question 34. An alternating current AC power supply is connected in series with a resistor R and a diode, which graph shows how the voltage across the resistor R varies with time. If we look at these graphs critically and look at the diode, the function of the diode is to serve as a rectifier in a circuit. It means it allows current to flow just in one direction. So if you look at this, current is flowing in two directions. So A is wrong. Current is flowing in one direction here, but let's look at the diagrams. Let's compare it. Okay, for C, since it is an alternating current, when current flows in one direction, it stops here. It is supposed to flow in another direction, but the diode will block it because it allows current to flow in one direction. So we have the pulse here, we have this one here, the diode blocks it, you have a pulse here, and it goes this way. This is the correct answer. This one does not give room for the pulse. Okay, 35. An electric heater is plugged into the mains supply using a fuse plug. The current in the heater is 10 amperes. The cable attached to the heater is rated 15 amperes. The fuses available are rated 1, 3, and 5 3, 5, and 13 amperes. Which fuse should be used? Now, we're talking about a current of 15 amperes. If you use a fuse of 1 amp, it will blow easily. This one blows easily. 5 amps blows easily. But if you use the fuse of 13 amperes, it can carry this, and when it gets to the maximum rating, that's 15 amperes, it blows. So this is the best and most economical fuse that you can use, and that is 13 amperes. The next question, which is question 36, what is the purpose of the commutator in a DC electric motor? Commutator is also called split ring, and the function of a commutator is to reverse the direction of current in the motor while for every half turn, and that is this. Let's go to the next question. The next question, and that is 37. The diagram shows a wire between two magnetic poles. The wire is connected in a circuit with an ammeter, okay? The wire is moved downwards towards the bottom of the page. A current is induced in the wire. In which direction is the force on the wire caused by the current? Force on the wire caused by a current. And that reminds me of Lenz's law. Lenz's law. Lenz's law, which states that an induced EMF moves in such a way as to oppose the force producing it. Let me extend this so that we get it very well. Now this is Lenz's law, which states that an induced EMF, here there is a current, so an EMF is induced. It moves in such a way as to oppose the force producing it. So the force is going to move in the opposite direction to the current. So the wire is moved downwards, then the force is going to move upwards towards the page. So towards the top of the page according to Lenz's law. Number 38, the chemical symbol of sodium is Na. The equation represents the reductive decay of sodium 24. What are the numbers x and y? This is very simple. When balancing an equation, here must be equal to here. If this is 24, this is 24. So that means y will be 0. We have this as y0, y0. So this is wrong, and this is wrong. Let's see how to balance this one. If this is 11 and it has lost an electron here, this one is going to be 12. And then you have 12 minus 1 to give you 11. So it is 12 and 0, and that is C. That means this is also wrong. Okay, let's go to the next question. Okay, 39. A radioactive source emits alpha, beta, and gamma rays into a vacuum where there is a magnetic field. The magnetic field acts perpendicularly into the plane of the paper. The path X, Y, and Z of the three types of radiation through the magnetic field are shown. Now, which radiation follows the path X, path Y, and path Z? Path Y, this is not deflected at all. Let me see. Okay. Path Y is not deflected at all, so that tells you path Y is gamma. So, this is wrong, and this is wrong. Let's get which one is the right one now. Okay. Path Z is deflected to the right, but it is deflected more than path X. And if you look at it, beta particles are fast-moving electrons and they deflect more in the magnetic field than alpha particles. And when they deflect in opposite direction to alpha particles. So the one that is deflected less here is alpha particle, that is X, and then Z is beta particle. So this is the answer. That's question 39. And then let's go to the final question. The final question, which is question 40. A student measures the level of radiation emitted from a radioactive substance. He places a detector very close to the substance. He puts different observers between the radioactive substance and the detector. The student's results are shown. These results are corrected for background radiation. Okay, here, okay, when there is no observer, 95 counts. Now, thin paper 52 counts. Thin paper 52 counts. When you have thin paper here and it has these counts, there is likelihood of alpha particles. And when they put aluminium, there is no change. So that means there is no beta, because beta particles penetrate few centimeters of aluminium. But here, there is no change. So no beta particles. And then several centimeters of lead, there is a change. So that means we have gamma rays present. No effect with aluminium means that there is no beta. There's an effect with thin paper, that means alpha. There's an effect with lead, that means gamma. So that means we only have alpha particles and gamma rays. Alpha particles and gamma rays. So that is the end of our tutorial for today, and I believe you have really enjoyed the tutorial. If you love what I'm doing on this channel, please subscribe to this channel and then turn on the notification bell icon so that you get notified anytime I post a new video. Thank you. I will be expecting you in the next tutorial.